us try an example to calculate the short-term losses of a pre-tension beam member. The sections is given here, and the details are FCK equals to 40 Newton per mm square. Modulus of elasticity of the steel tendon is 195 gigapascal. T is equals to 3 days. Cement type R. Add numbers of 7 wire standard strength 15.2 mm diameter. Total pre-stressing force is equals to 1200 kN. The centroid of the eccentricity will be 450 mm, and the beam has an effective span of 12 meters. You may pause the video for a while for you to work out the solution. To solve these questions, first you need to know that the pre-tension member only has the elastic losses. There will be no friction and drawing losses. Therefore, our calculations will focus on the elastic losses. As for the equations to be used, these equations is used to determine the elastic losses for the pre-tension member. Within the equations, there are parameters of the steel tendon, concrete, and also the geometrical properties of the section. First, we look into the concrete part, which is secant modulus of concrete at the day of the transfer, as given in the formula here. It is in the functions of the secant modulus of elasticity of the concrete and in the functions of SCM and FCMT. To determine the FCM, this equations is used. Concrete grade is 40, FCM will be equals to 48. Next, we determine the ECM based on this formula. Substitute 48 into the equations, you get ECM here. The S here will need to refer to a table as given here. Cement type R is being used, therefore the S is equals to 0.2. The T is given as 3 days. Substitute the relevant value, you obtain FCMT, which is 31.8 Newton per mm square. And substitute the relevant value into the equation here, you get ECMT here. Modulus or elasticity of the steel tendons is given here. APS is calculated by multiplying the numbers of the tendons and their cross-sectional area. The A, E, and I refers to the geometrical properties of the sections, which we have calculated in the previous example, in the previous chapter. And the pre-stressing force is 1200 kN. Substitute all the relevant value into the equation here, you obtain the percentage of losses is equals to 7.4%. In terms of the magnitude, it is about 88.8 kN. Since the member is a pre-tension member, the following losses is irrelevant. These include the frictions and wobble and also drawing of wedges. With that, your total short-term losses will be only 7.4% out of 1200 kN.